Hello, the topic of today's lesson is finding volume of a solid. And this is basically using Archimedes principle. Archimedes principle. You can look up a video online. There's so many beautiful animation principle explaining the Archimedes principle. But in summary, it states the following. Let's label this before. Let's label this after. It states the following, that if we have water in a container, be it a cylinder or a bathtub or a sea or a fish tank, if we add solid objects, and here we have some marbles, right? The water level will rise. We call it displaced water. It will rise up exactly according to the volume of the objects that were placed in the water. So the amount of water that will be displaced, in this case, we add some solids into the beaker and the water level rises. We call it displacement, right? It goes up, the water level goes up. I'm sure you've seen this as you're taking a bath or if you're like washing some fruit in a bowl, the water will always splash out according to the volume of the objects that were in the water. So, step one, before we had a volume of the water that is 50 cubic centimeters. Now think of it as a movie. Volume of water and the marbles is now 80 centimeters. So what happened? Volume of the marbles alone must be 30 cubic centimeters. The volume of 1, 2, 3, 4, 5, 6, 7, 8 marbles is 30 centimeters cubed because that is exactly the volume that was displaced after they were placed inside the beaker. Let's use this information to calculate the volume of objects placed in the water. Objects, they call them solids. Again, we're going to talk about a lot of fish tanks. A rectangular tank is 30 long by 20 wide. So length equals 30, width equals 20. Always label what is given. It is filled with water to a depth of 8 centimeters. Depth, height, we can use these terms interchangeably. The height of water is 8 centimeters. When the stone was put, so this was the situation before, and this is after. When the stone was put inside the tank, the water level went up. Of course it went up. Before it was 8, and now it is 11, right? 11 centimeters, which means it added plus 3 centimeters of height. Find the volume of the stone. Find the volume of the stone. It's a very neat and easy way to measure, approximately, not exactly, the volume of the stone. Let's look at the volume of displaced water. So, step one, we know that the water level, the height of the water level changed by 3 centimeters, 11 minus 8. Volume of the displaced liquid, step two, we can find the volume, length times width times this change of height. So we know that the bottom face is 30 by 20, so it is 600 times 3 is 1800 cubic centimeters. Therefore, we conclude that the volume of the stone is 1,800 cubic centimeters because that is the volume of displaced water. The volume of the stone, you see how what a neat method to measure the volume of solids, because it would be very clunky to measure the volume of irregular shapes such as this brown stone. Let's take a look at another example. We again have a rectangular tank that is 30 by 18. The length equals to 30, width equals to 18. I recommend you label what is given on your drawing. We have a different problem. It had a stone. When the stone was taken out, the water level dropped by 2 centimeters. You see, dropped. It was higher now, and now it reduced. Of course, let's draw the situation before. It's always helpful to make a situation before. We had some kind of stone, and of course it was 30, and of course I can make a simple drawing by 20, and we had some water level, right? Because the stone was inside the water. When the stone was taken out, this was before, and now we have the situation after. The water level dropped by 2 centimeters. So we now know that the water level change, that the decrease, right now we don't have water right here, is 2 centimeters. What was the volume of the stone? Well, we know the bottom face is 30 by 18, right? So the area of the bottom face is 30 by 18, and the volume of water that was decreased as the result of the stone being taken out, right? The water was decreased, right? That's the new water level, 2 centimeters lower. So that means this volume, this difference attributed to the stone's volume is 4,000, well, 30 times 2 is 6, 6 times 18 is 4,800. 4,800 cubic centimeters. Next page, we have a rectangular container, again, the fish tank, that's 15 by 10. Always label what you know. Length equals 15, width equals 10. It contains water to a depth of 4 centimeters. So, we again have the situation that is not shown of a tank. And that is 15 by 10. And it has a volume, depth of water that is 4 centimeters. 4 centimeters. When a stone of 300 cubic centimeters is put in, so this is before, empty fish tank, right? Before. And this is after. What happened? The stone was added, right? We have some kind of stone. It was added, and the volume of the stone was 300 cubic centimeters. The water level, of course, goes up. Once this stone is added, the new water level is higher, okay? So that means this red portion is attributed to the stone. That means this red volume, the volume of this water is 300 cubic centimeters. So this is one of those problems where we know the volume, we know the length and width. We're looking for the change of height. We're looking for the height, right? Let's label this H is question mark. So step 1, I'm going to pick up a blue pencil. Step 1, what is the increase in the water height? Well, this is your volume and this is your length times width. So we know that the volume of water, that red level, was due to 2 centimeters. 2 centimeters of increase. And what is the new water level? The new water level, well, before it was 4 plus 2 equals 6 centimeters. The new water level is 16 centimeters. Now, finally, problem number 4. Again, we have a rectangular container. It's 9 by 6. Length equals 9, width equals 6. It was filled to a depth of 5 centimeters. So height before was 5 centimeters. Height after some marbles were added, right? It became 7 centimeters. What happened? Of course, we have a change. We have water displacement. The moment we add an object to a container full of water, we will have some water level going up. It's called displacement. In this particular case, the change of water level is 7 minus 2 equals, 7 minus 5. I'm so sorry. 7 minus 5 is 2 centimeters, which means this height equals 2 centimeters of this purple water that was displaced as a result of the marbles. Therefore, find the total volume of the marbles. Well, it's a multi-step process. Step one, we have the old water level, right? Volume before is, we need water volume of, we can do it different ways. Volume before equals 9 by 6, and of course times 5. And that is 9 times 30 equals 270 cubic centimeters. Now, step 2, volume after the marbles were added is still 9 times 6, right? The fish tank didn't change, but now we multiply it times 7 because the new height is 7, right? Height after is 7. So 9 times 6 is 54, and times 7 is 378. So the volume before was 270. The volume after the marbles arrived is 378. Therefore, step 3, volume of stones alone must be 378 minus 270, right? The difference. And that is 108 cubic centimeters. 108 cubic centimeters. I hope you found these problems interesting and useful.